Hello everyone, welcome to the new session 6 on projection of solids, that is projection of pyramids. Now we are touching upon problem 13, that is this from problem 13 onwards. Okay, we are doing some problems on hexagonal pyramids. In this problem, there is an hexagonal pyramid of base height 60 and height 150 as one of its base edges on HP with axis inclined at 30 degrees to HP. Draw projections of this hexagonal pyramid when edge on HP is inclined at 40 degrees to VP. Assume base is nearer to the observer, adopt 1:2 scale. Because since the dimensions are big and all that, it's better you take 1:2 scale. Now, you see here, hexagonal pyramid has one of its base edges on HP. That is why you start the hexagonal pyramid in this position. Okay, this is 60, all 60s. That means if you want to, once you complete hexagon, regular hexagon, it will be 6 edges. And the intersection, that is, if you draw the diagonals and all that, you get O1 here. That means OA, OB, OC, OD, OE, OF. Along with base edges, 6 edges, it will be totally 12 edges. Now, in the front view, if you want to write, this height is 150, and if you're taking a scale of 1:2, you are actually writing it as 75. Even here also, you are taking a scale of 1:2, you actually write it as 30 mm. Now, this point will be, since B is nearer, B dash A dash, since C is nearer, C dash F dash, since D is nearer, D dash E dash, and axis is O dash O1 dash. Now in this position, if you tilt right or left, it will be resting on base edge only on HP. If you tilt right, it will be resting on D on HP. If you tilt left, it will be resting on edge AB on HP. If you completely tilt right, it will be resting on triangular surface ODE on HP. If you completely tilt left, it will be resting on triangular surface OBA on HP. Okay, but in this problem, it is resting on edge on HP such that the axis is inclined at 30 degrees to HP. That means move copy and then rotate in such a way that the axis is inclined at 30 degrees to VP. Its axis is inclined at 30 degrees to HP. In this position, we are expected to write on top view. Then take the projectors down. Take the projectors down from the front view. Then, as I told you in the earlier steps, complete the outer boundary of these points. Once the first step is over, go to the second step. Compare apex with the base. Since apex is nearer than the base, remaining edges of the base cannot be seen. Hence, EF, ED and DC, you make it invisible. Now you count the number of edges after the end of second step. That is 6 plus 2, 8 edges are over. Now you have to complete 12 edges. As you are aware, you are supposed to complete 12 edges. Now already 8 edges are completed. Now you have to complete 4 more edges. Now when you are looking from the top here, OB and OA are nearer edges. Immediately you darken OB and OA. And OD and OE are faraway edges when you are looking from the top, bottom edges. Hence OD and OE are invisible. In that way you are able to complete the top view with 12 edges. Then you show the axis also. Now what you do is, as per the problem, the edge on HP is DA, which is inclined at 40 degrees to VP. That means move, copy and rotate in such a way that the DE is inclined at 40 degrees to VP. Second stage top view will be same as third stage top view. Okay. Now once you do this, the procedure is take the take the projectors to the front. All the points you see here, on this you should get O, on this you should get AB, on this you should get C and F, on this you should get D and E. Okay, and as I've told you earlier in earlier sessions and all that, first step is always the outer boundary. In that way, outer boundary is darkened, 0.5 mm thickness, directly darken the outer boundary. Now you are looking from here, since base is nearer than the apex, darken the base. In that way, A dash, B dash and B dash, C dash and C dash, D dash, you darken it. Now you count the number of edges. It is 6 plus 2, 8 edges are over. You have to complete 4 more edges. That is O dash, B dash, O dash, C dash, O dash, F dash and O dash, E dash. Now if you look at this, B and C are nearer corners. Nearer corner edges can always be seen. Hence, darken O dash, B dash and O dash, C dash, and F and E are faraway corners, and edges from F and E corners are invisible. As a result, O dash, F dash and O dash, E dash, you make it invisible. And finally show the axis as O dash, O dash. Now we'll go for problem number 14. This says a hexagonal pyramid of base sides 60 and height 150 has one of its triangular faces on HP with top of the axis inclined at 40 degrees to VP. Draw projections of this hexagonal pyramid, assuming apex to be nearer to the observer. And obviously, since the dimensions are big, we are taking a scale of 1:2. Now you see here, write the top view as usual, hexagonal pyramid, and immediately write the corresponding front view 150. And if we are taking a scale of 1:2, this you take it as 30, this you take it as 75. Now, as I told you earlier, if you completely tilt right or left, it will be resting on triangular surface on HP. That is what we are interested now. That is why, since the problem says it is triangular surface on HP, immediately completely tilt right so that O dash, D dash, E dash is the triangular surface which is on HP. Now, take the projectors down and complete the outer boundary of these points as the first step. Now compare apex with the base. Now when you are looking from here, base is exposed to the observer, base is nearer to the observer. As a result, base can be seen, darken the base. Now it is 6 plus 2, 8 edges are over. You have to complete 4 more edges. One is OA, one is OB, one is OC and OD. Observer is looking from here. OB and OA are near edges. Darken it. OD and OE are faraway edges. Make it invisible. That is, OA and OB are darkened and OD and OE are faraway edges, which you make it dark dotted, invisible. Show the axis also. Take the projectors and draw the axis. Now the problem says the top view of the axis is inclined at 40 degrees to VP, and you do in this way so that apex is nearer to the observer. 40 degrees you can do this way also so that base is nearer to the observer, but the problem says assume apex to be nearer to the observer. In that way you do this way. Now second stage top view, move, copy, rotate in such a way that axis is inclined at 40 degrees to VP or XY line. Okay, then as I told you, obtain all the points in the other view and join the outer boundary of these points by dark lines. Now as you see here it is a triangular surface, 3 edges are here only, 3 here, 4, 5, 6, 7 edges are already over. Since apex is nearer than the base, remaining edges of the base is not seen by the observer. You make it dark dotted. Now you count the edges. It is 3 here, 4, 5, 6, 7, 8, 9 edges are already over. Okay, you are now left with O dash, F dash, O dash, C dash, O dash, B dash. Okay, 3 more edges have to be drawn. Now you see O dash, C dash is the C, as you see here, OC is the nearest edge which you can darken it. OB also comparatively nearer corner edge, that also you can darken it. OF is F is a faraway corner for an observer who is looking from that, who is looking in this direction. As a result, you make it dark dotted. In that way, OC, O dash, C dash, O dash, B dash, you darken it. O dash, F dash, which is faraway edge, you make it dark dotted. Okay. In this way, you are completing a problem on hexagonal pyramid, which says that a hexagonal pyramid of side 60 and height 150 has one of its triangular surfaces on HP with top of the axis inclined at 40 degrees to VP. Now we'll go for the problem number 15. It says a hexagonal pyramid of base sides 25 and height 50 has one of its slant edges on HP with top of the axis inclined at 45 degrees to VP. Draw projections of this hexagonal pyramid in this position when the base is nearer to the observer. Now, you see here. Now it is, you have to change the position of hexagonal pyramid because when you completely tilt right or left, it should be resting on slant edge. Okay. This position is called the corner position of hexagonal pyramid. Okay. Unlike the previous position which is called the edge position. Okay. Now you draw hexagonal pyramid in this position and draw OA, OB, OC, OD, OE, OF and O1 being the axis. Totally 12 edges are here. In the same way, complete the front tube. Okay. Complete the front tube with height as 50. This A dash. This B is seen, F is not seen, B dash, F dash. C is seen, E is not, C dash, E dash. This is D dash. And this is O dash, O dash, which is the axis. Now it is 6 edges here, 7, 8, 2 edges here, 2 edges here. That is OB, OF must, OC and OE must. In that way, 1, 2 here, 2 here, 1 here, 6 edges here, 6 edges here, totally amounting to 12 edges. Now, he says in this problem it is resting on one of its slant edges on HP. That is why completely tilt right, you can even tilt left also, such that it is resting on one of its slant edges on HP. Now, once it is resting on slant edge OD on HP, get all the points in the other view, join the outer boundary of these points. Since base is nearer to the observer, darken the base. Now you count the edges, 6 plus 2, 8 edges are over. Okay. Then, since OA is nearer, darken OA. Okay. And OE and OC are far away and OD is also far away. In that way, you make it invisible. And OD, invisibility can be seen only between A and D. Now, what you do is, show the axis also. Now what is the thing is, the problem what they given is, axis is top, O1 is the top view of the axis. The top view of the axis is inclined at 45 degrees to VP. Copy and move and copy and rotate in such a way that top view of the axis is inclined at 45 degrees to VP. Take this position, take it to the front, complete the outer boundary. Since base is nearer, darken the base. 6 plus 2, 8 edges are over. Then you are left with one edge O dash C dash, O dash E dash, O dash F dash, O dash A dash. O dash C dash being nearer, darken it. And all other edges E, F, A are comparatively back corners which are to be made dark dotted, invisible. And finally show the axis O dash, O1 dash. This completes the section 6. Thanks for watching.